Okay, yesterday I taught you enough that you should be able to take this and give me a sketch of what this graph has to look like. It's got a squared in it, so you know it's even. It's got a negative in front, so you know something else. You know the y-intercept of it. You should be able to get a kind of medium accurate idea of what this thing looks like. Okay, so I'll give you a moment. Go ahead and make a sketch. And then I'll tell you how you could have made it more accurate in just a moment. I'll pause while you work on that. Back to our problem from the beginning. Would you please tell me what the y-intercept is? The y-intercept is 5. Finish this sentence. Excuse me. The y-intercept is where what? X equals 0. Okay. Right this way. Thank you. Stay focused. The y-intercept is where x equals 0. So if I put a 0 in here and I put a 0 in here, yes, that 5 is the y-intercept. I don't want you to think that the 5 is always, the last number is always the y-intercept. It's not. It's wherever x is 0. Okay, so 5 is correct. That's the y-intercept. Now what else do I know? I know that it's a parabola because it's got squared. I know that. How about this? Do both ends go the same direction? Yes, because it's even, because this is an even number, they are the same. As in, they're either both up or they're both down. And in this case, what are they? They're both up or down? Both down. Okay. So it's got to go through 5, and they got to have both ends going down. And if you had something like this, that was good. Raise your hand if you had that right. Okay, good. Now, how can we get that more accurate? Here's how. If this was in factored form, as in if you could factor this, which of course you can, if you could factor this, you could know exactly where it touches here and here. Okay, would you right now factor that? If you don't know how to factor, this is the part where you say, I shouldn't have taken this pre-calc class because I don't even know how to factor. I know, it's kind of a hard one. I will give you a hint. You want to start by factoring out the -1 in front. All right, so if you factor out the -1, it looks like this. 2x squared minus 9x minus 5. I know a lot of you wouldn't have known that, so I'm going to help you out with that part. You want to factor out the -1 first. Next step, got to set 2 parentheses. Two x and x. Even a child of age 8 could do that. But this next part is kind of hard. So you go, all right, you can't just say what multiplies to 5 and adds to 9. That's not what we do on this kind. Instead, you have to go, if I look at the outside and the inside, they have to make a total of -9. So how can I make this come out to the outside and the inside making -9? A -1 and a +5? Is that what you're saying? -5? Like that? Close, except now, there we go. Now I can check. Outside, -10. Inside, +1. Total, -9. Yay, it worked. Okay, so I factored it. So now what? Now I know what these 2 spots are, here and here. You know what they are? They are whatever would make these parentheses equal 0. That's called the zeros. Okay, so this has still got a y equals at the beginning of it. So now, if I have this part right here set equal to 0, -2, sorry, not -2x, 2x plus 1 equals 0, and I set this equal to 0, x minus 5 equals 0. Set them both equal to 0. I've had this on the top 20 sheet over and over again. We've been practicing these. You should be good at them. 2x equals -1, x equals -1/2. And this one over here, x equals 5. There's 2 answers to this kind. So what does that tell me? That tells me that this spot here was +1/2. No, I'm wrong. X equals -1/2. Sorry. This spot here is -1/2. And this spot over here is +5. A -1 just makes it flip. Remember that? How there's a negative in front, it makes it flip? That's why this parabola is upside down. It's because of that -1. Make sense? And the other thing it would do is stretch it, but the stretch factor, we don't need to see how it's stretched. It's a factor of 1. It's not really stretching it, really. The negative is just flipping it. All right, I know that was kind of intense, but the point is, you now can see from an equation, if it's written like this, you can go, oh, I know not only that it's a parabola, because if I multiplied that all out, it would be squared. I also know that it's got a root of -3, and it's got a root of 2. So it goes through -3, and it goes through 2. You get that? All right. So your next step is, if I was going to actually graph this thing, would it go like this? Yes or no? No, why not? Not a negative in the front. Good. Has to be going up on the right. So if it's got to be going up on the right, how about the left? Does the left go down or up? Up, because this has a power of 1, and I hope you know this. When you're finding the degree on this kind, you add these together. That's degree 2. So this is an even one, and therefore both ends have to either go up or down, and we've established there's no negative in front, so it has to be going up on the right, so therefore it must be going up on the left. Last thing. I know that it can't be doing that. And why? Because of the turn thing. How many turns does this have in it? It's got 1 turn, 2 turns, 3 turns. That would have to be at least a degree 4. You see our equation? Our equation is not a degree 4. So that would not have been an okay way to do it. So how do I do it? You can just make it simpler and go like that. I might ask, how can I know what that y-intercept is? Fill in the blank. The y-intercept is where x equals 0. So I just plug in a 0. I stick a 0 in right here. 0, 0. What do I get? What's that? 3, what's that? -2, what's 3 times -2? -6. See, I know that's -6 down there. All right, so we're being more accurate than yesterday. Now we can not only draw the graph, we can tell where it touches here and here. All right, here's another one that's a little more complicated. Let's see if you can hang with it. Do you agree it touches at 7 and -4? That is a correct assumption. Touches at 7, touches at -4. Okay. What's the degree of this one? Degree 3. Good. So that means the ends go opposite directions. Is this one leading with a positive or a negative? Therefore, it's going up on the right. Now, here's the tricky part of this one. If it's going up on the right and down on the left, that little squared is telling you something. Do you remember this from last year? You actually were exposed to this last year in HA. It bounces. This is a bounce. How many of you remember that? In the back of your mind, you remember that square being bounced, okay? Like half of you. That means that half of you didn't process this last year, but you have to learn it now. It's bouncing at the 7. That 2, that means that it's a bounce there. Boing. I missed. I'm going to try again. Boing. And now at the 4, it's not bouncing. It's a 1. That's called a cut through. There's my final answer. Oh, wait. I never checked my y-intercept. Could I possibly know what the y-intercept is? Yes. You just have to set x equals 0. So I go put in a 0 here and here. And I'd have -7 squared, which is 49 times 4. Holy crap. 49 times 4? That's almost 200. It's 4 less than 200 to be 196. So apparently that is at 196. Did I do it wrong? That's 49 times 4. I think I'm right. All right. So what's the last kind? Here's the ultimate. See if you can handle this one. Let's make this darker so it's easier to read. All right, let's make that something farther away, not +2. Make it like -5. And then let's make this last one x +7. There we go. Sketch that for me. You should be able to know the y-intercept, which is a ridiculously big number. You should, or is it a ridiculously small number? Anyway. And you should be able to tell me what the x-intercepts are, the roots. You should be able to tell if it bounces at them. That's a xy axis. Got a good start. Give it a shot. So the way I'd start, I'd probably figure out the y-intercept. Three cubed 27 negative, so it's negative 27. 5 squared, or negative 5 squared, 25. 7. Wow, that's a big number. It's a huge number. Is it positive or negative? Negative huge number. Okay, so I'm going to just put a dot way down there and say it's negative some huge number. Don't need to know exactly where it is. We'll give you numbers that'll be nice, very reasonable. You'll be able to see it's like, oh, it's negative 5. All right, next step, figure out the x-intercepts. Those are easy. Negative 7, 5, and negative 3. Here's negative 3, here's 5, here's 7. Oh, wait, that's negative. I got to make negative 7. Okay, so it's got to go through those spots. Who can tell me something else smart about this graph? Down on the right. Why? Because of that. It's got to be down on the right, so it's got to be going down over here. How about where it hits the 5? Bouncy, yep, because it's got the squared, it's bouncing there. Boing. How about where it hits the 3? The snake. I don't know if you remember this one. I'll give you a zoom in on what they generally look like. That, it's kind of like the x cubed thing, or that. Okay. So now if I'm hitting this 3 right, I got to be going like this and then change to like that. It's okay with me if you're really having trouble drawing it and you're like, because I have trouble even, and I've been teaching this a long time. If you want to label it as a snake, then I'll know, oh, they're trying to draw that little S shape going through there. And then the last one, that's 7. Is it a bounce? Straight through, so you go like that. Now it's going down on both ends, but isn't it a degree 5? No. That one end makes a degree 6, therefore they're both going down. It works. This is a good graph. It's not perfect, still considered a sketch. But what I'd be looking for on the test, I remember grading these. I'd be looking for these spots right here, here, and here. And I'd be looking for both ends. And if the ends are going the right direction and you had these spots right, it was usually good. The only other thing is, every now and then somehow somebody would mess up their y-intercept. I would also check their y-intercept for being at least on the right side of the axis.
What about power 4?
Good question. What is... These are the 3 you have to worry about, but what is a to the 4th power? Just so you know, y equals x squared kind of looks like this. Y equals x to the 4th is just narrower, and it's basically a tighter bounce. That's all it is. So it's still a bounce, just tighter. But don't worry, we're not going to put any to the 4ths on your tests. You'll be expected to know to the 3rds, 2nds, and 1sts. All right. Okay, so that covers a lot of it. I think what we should do is actually just do some of the worksheet problems now. So here is your worksheet for today. Remember, test coming when? Monday and Tuesday. What? St. Thomas. What just got canceled? A tournament there or something? Or a game? Or? Oh, wow. Wow. Holy cow, you already said 17 inches of snow in Duluth? That's nuts.
My wife's car is like covered. Like it's almost flat.
That's awesome.
And then it's still snowing really hard right
Huh.
now. But then they're gonna get more like hands tomorrow.
All right. Well, we can pray, but I'm not feeling a snow day quite this early. Never know, but
Snow tonight, tomorrow.
I think it's a little too early in the season. Usually we get our, although we did have a snow day on Halloween one year. That was many years ago. That was, you may not have even been born.
That was 96. I was not born.
Okay, there you go. Yes.
I think.
All right. I need to do some problems with you. Let's look at number 1. Numero uno. And by the way, this assignment is a smidge long, so I'm going to have you skip some lucky numbers. You're going to be skipping number 7 and number 11. Those are the craps numbers in the game of craps in Las Vegas. And then we'll skip Sweet 16. 7, 11, 16. That will make it a little bit more reasonable assignment. Please keep getting your homework done. It really, really helps you. It really, really, really does. And it also goes in the grade book, which helps you grade too. All right, number 1. On that one, you want a sketch of it, and they said be accurate with y-intercept and n behavior, and if it's in factored form, which number 1 is, be accurate with the x-intercepts and the behavior at the x-intercepts. So basically, we got to be accurate on a bunch of stuff. All right, first thing, can anybody tell me the y-intercept? You already figured it out yet? Y-intercept is where x is 0, right? So it's -6. You are correct. So I'm going to make a little spot on my graph, label it -6, and I know it has to touch there. Okay. Next thing, the end behavior. Let's just make a little arrow on each end that tells us which way it goes. Now look at the degree. What degree is it? It's degree 3. For those following along at home, it looks like this: x minus 1, x plus 2, and x plus 3. And that's degree 3 because there's a 1 and a 1 and a 1. You add them all up and you get degree 3. All right, so if this is degree 3, then it's odd. That means that since it's leading with a positive number, it's going up on the right and down on the left. I would make little arrows like that. Next thing, if it's in factored form, which it is, be accurate with the x-intercepts. Okay, so in other words, I got to make it touch in the right spots here. I can't just like randomly pick spots. I have to know where they are. Where are they? -3, -2, and 1. All right, so I got to touch at 1, and I got to touch at -2, and I got to touch at -3. So how can I start in the downward direction, then come up through -3? I'm going to try it here, see if this works. There, there, there. The only thing I'm not sure of is my y-intercept. And oh, wait, I know my y-intercept's -6, so I better be more careful. I didn't hit -6. So I'm going to go there and then up through there. Anybody got a bone to pick with that? I think it's right. I think it's good enough. Spots I'd be looking for are this, this, and this. And I'd be making sure you went through the y-intercept correctly. And I'd check your end values. So these are all the spots I would check. All right. Moving on.
After the ones who aren't in factored form.
Good question. It says only if it's in factored form, be accurate. The other ones may not even factor. So no, when you get to like number 3 and number 4, don't try to factor them. They probably aren't going to factor. They might, but you could spend a long time trying to figure out if they do. All right, let's move on to like number 10. That one freaks a lot of people out, or even number 9. Let's do number 9. It's a little bit easier. Number 9 freaks people out because it's factored, but it doesn't look like all the others. That X in front throws people off. They say, well, I know it goes through 3, but what's this X supposed to be doing? It's 0. Now, why? Wouldn't you agree that I could write this as X plus 0? Isn't that the exact same thing as just an X? And how does that help? It helps you see that that's just what makes that parenthesis 0 if X is 0. So 0 and 3 are my 2 spots on this one. 0 and 3. Here's 0, here's 3. And then I got to make it bouncy at the 3. And its lead coefficient is positive, so it's going up on the right. Total degree is degree 3, that and that. Since it's degree 3, it's odd. It's going opposite directions, so it must be something bouncing there like that. Okay. If you flip it to the other side, number 13 asks you to use limit notation. First, though, you got to sketch the graph to have any chance of knowing which way it is going. Is it going up on the right or down on the right, or up on the left, down on the left? So on number 13, all I really need is a quick sketch, and then I can write the limits. Since it's negative, what's that tell me? Down on the right. Good. Since it's got a y-intercept of 3, I can go through here. And since its a degree is 3, I know it's odd, so it's got to be going up on the other end. So I could do something like that. Doesn't even really matter that much as long as you got the end behaviors right. Why do the ends matter? Because we're doing the limit, and the limits are talking about the ends. So here's how you write all your limit answers. Limit of the function as x approaches, and then you say equals. Every limit you ever write from now till the end of time will have that in it, at least in my class. Is this degree 6? No. You don't add them unless they're in parentheses. If they're in parentheses, then you can add up the powers. If they're written out like in standard form like this, you just take the biggest one. It's only if they're factored like this that you want to add the degrees and get degree 3 that way. Okay, anyway, let's go back to the limit on the left end. Is going to be, on the left end, you're going x to negative infinity. And then when you get way, way, way to the left, you get that the graph will have gone way, way, way up. So therefore, it is positive infinity. And on my other end, the limit of the function as x approaches infinity. If I go way, way, way to the right, where's the graph going to end up? Way down, which makes answer what? Negative infinity is correct. That's an example again of limits from yesterday. All right, you got a bunch of time to work. Use it. And if you have questions, please come up and ask.